Alright, the next topic that we're going to learn is how to use sigma notation and how to find the measures of dispersion relative to the mean. So we will discuss three ways of examining the dispersion of data. We are going to discuss mean absolute deviation, standard deviation, and variance. Summation is something that is done quite often in mathematics, and there is a symbol that means summation. That symbol is the capital Greek letter sigma, denoted by this symbol, and so the notation is sometimes called sigma notation instead of summation notation. So we can use either sigma notation or summation notation. Here's an example of a sigma summation. So our I here is called the index of summation. This is our lower limit, and this is our upper limit. This notation tells us to add all of the a subscript of I for all integers starting at 1 all the way to n. Here are some examples. So I have summation of a subscript of I, where I ranges from 1 to 5. We just have to replace your I by 1, and then by 2, by 3, by 4, and then by 5, and then we have to add everything up. Here's the second example. Summation of 2x raised to 3, where x ranging from 1 to 4. So what we have to do here is to replace x by 1, which is this. The second term, replace your x by 2. The third term, replace your x by 3. And the last term, replace your x by the upper limit, which is equal to 4. And then simplify the exponents. You will have 1 raised to 3, which is 1. 2 raised to 3 is 8. This is 27, and this one is 64. Simplifying each product, you will get 2, 16, 54, and 128. Add everything up, we'll get 200. Another example, summation of 2n minus 3, where n ranges from 4 to 7. So again, replace your n by 4, you will get 2 times 4 minus 3, plus, replace your n by 5, so 2 times 5 minus 3, plus, replace your n by 6, 2 times 6 minus 3, plus 2 times 7 minus 3. Simplify each term, we'll get here 8 minus 3, this is 10 minus 3, 12 minus 3, 14 minus 3, this is equal to 5, 7, that's 9, and then 11. Add everything up, we'll get 32. So these are the different measures of dispersion relative to the mean. We have the mean absolute deviation, represented by this formula. We have the variance, and we have the standard deviation. So deviate means to turn aside, or to depart or swerve as from a procedure, course of action, or from an acceptable norm. Deviation. So let's start by finding the sum of the deviations from the mean. So let's say we have here heights in inches. So I have here 1, 2, 3, 4, 5 different heights. So we have to get the mean first, and the mean here is equal to 74. So again, to find the mean, you add everything up, divided by 1, 2, 3, 4, 5. So divided by 5. Next, let's find the average deviation from the mean. We are going to subtract 74 from each of these heights. So we'll have 72 minus 74, 76 minus 74, 68 minus 74, 80 minus 74, and then 74 minus 74. We'll get the following numbers. We are going to, well, if we are going to get the average of this, it will be equal to 0. And this is always the case. Whenever we get the average deviation from the mean, it is always equal to 0. So this is the deviation. Once we get the average, add everything up, you'll get negative 2 plus negative 6 plus 6 plus 0 divided by the number of terms 1, 2, 3, 4, 5. So we have 0 divided by 5. The result is equal to 0. The average deviation from the mean is always equal to 0. Next, let's take the absolute value. So the absolute value of negative 2 is 2. Take the absolute value, we are going to get the following numbers. Next, let's get the average. So 2 plus 2 plus 6 plus 6 plus 0 divided by 1, 2, 3, 4, 5. So we have 16 divided by 5 equals 3.2. So this 3.2 is our mean absolute deviation. So our mean absolute deviation formula can be represented using sigma notation. So we take the sum of the absolute value of the difference of each element and then the mean divided by n, where mean is represented by mu and n is the number of items. Alright, I have here 5 different heights. Again, we find the mean, 72 plus 76 plus 68 plus 80 plus 74 divided by 5. The result is 74. Next, if we are going to use this formula, we are going to replace our I by 1. So we'll get x of 1 minus the mean. So our x of 1 is 72. So 72 minus the mean. So x of 2 minus the mean, x of 3 minus the mean, x of 4 minus the mean, and x of 5 minus the mean. So we just replace your I here by 1 to 5, up to 5 because we only have 5 numbers in here. Now x of 1 or x sub of 1 is 72, so replace this by 72. X of 2 or x sub of 2 is 76. This is our x sub of 3. Replace x sub of 4 by 80. Replace x sub of 5 by 74. And then divide by the number of elements. In this case, we have 5. So take the difference and then the absolute value. The absolute value of this, we just have to take the absolute value of each of these numbers, sum them up, we'll get 16, then divided by 5. That's how we use this formula to get the mean absolute deviation. So here's an example using the table. So we have the same data in here. Okay, 72, 76, 68, 80, and 74. So list all your elements in the first column. Of course, don't forget to find your mean, which is 74. Next, we have to subtract our 74 from each of the numbers. So we'll have 72 minus the mean, 76 minus the mean. We get the difference. Now, take the absolute value of each of the difference. So this is the absolute value of these numbers. Now, once we get the average, okay, 2 plus 2, which is 4, plus 6 is 10, plus 6 is 16, plus 0 is 16, divided by 5, we'll get 3.2. Alright, let's have another example. So test scores for 6 students were 71, 73, 69, 72, 67, and 68. Let's find the mean absolute deviation. Okay, so we have here 3 columns. List all the test scores in the first column. We have to get to the mean, so we have to add 71, 73, 69, 72, 67, 68. The sum is 420 divided by 1, 2, 3, 4, 5, 6. So our mean here is equal to 70. Next, subtract the mean from each of these numbers. So this is what we call the deviation from the mean. 1, 3, -1, 2, -3, and -2. Once we get the average of this deviation from the mean, the result should be equal to 0, the average. So I have 1 plus 3 plus -1 plus 2 plus -3 plus -2 is equal to 0. And if you take the average, 0 divided by 1, 2, 3, 4, 5, 6, so 0 divided by 6, the result is 0. And as what I've said earlier, the average deviation from the mean is always equal to 0. Next, let's take the absolute value. So take the absolute value of 1, take the absolute value of 3, take the absolute value of -1, which is 1, absolute value of 2 is 2, absolute value of -3 is 3, absolute value of -2 is 2. Now let's take the average. 1 plus 3 plus 1 plus 2 plus 3 plus 2. The result is 12. Let's get the average. So 12 divided by 1, 2, 3, 4, 5, 6. So divided by 6, we'll get 2. So 2 here is our mean absolute deviation. Alright, another example. I will just ask you to solve for this data. I need you to find the mean absolute deviation. So pause your video right now, practice on this data, create your own table, find the mean, then subtract the mean from each of these numbers, get the average. You should be able to get 0, and then once you take the absolute value, sum everything up, and then the result will be your mean absolute deviation. Alright, so this should be the value of the mean absolute deviation. It should be 18. Let's have our last example. Given the data set below, find the mean, find the sum of the deviations, and find the mean absolute deviation. So I have 2, I have 1, 2, 3, 4, 5, 6, 6. 1, 2, 3, 4, 5, 6, and I have 2 8s. First, let's find the mean. 2 plus 6 plus 6 plus 6 plus 6 plus 6 plus 8 plus 8. That's 54 divided by 9. So we have 6. So our mean here, mu, is equal to 6. Now subtract the mean from each of these numbers. So we have 2 minus 6, 6 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 minus 6, 8 minus 6, 8 minus 6. So we have here -4, it's 0, 0, 0, 0, 0, 0. That's 2. That's 2. So once we get the sum of our deviations, so negative 4 plus 2 plus 2 is actually equal to 0. Sum of deviations is always equal to 0. Now find the mean absolute deviation. Let's take the absolute value of negative 4. It is equal to 4. Absolute value of 0 is 0. Absolute value of 0 is 0. So all of these will be 0. Absolute value of 2 is 2. Absolute value of 2 is also 2. Sum everything up. 4 plus zeros plus 2 plus 2 will have 8. Get the average. So 8 divided by 9 will have, so 8 divided by 9 is equal to 0.89. So 0.89 is our mean absolute deviation.